Yeah. Hi guys, we're Team Pepper, and this is our project Job Salt. I'm Ross. I'm the project manager.
I'm Colton. I'm in charge of communications.
I'm Dave Lamont. I'm our system administrator.
And I'm Daniel Wallach. I'm lead developer.
So our project is slightly unique in that we actually have not only 2 sponsors, but we also have a 5th team member who doesn't go to RIT. He actually goes to the University of Arizona. He is currently working for Chris Jansman out at the University of Arizona, and he's, as a student there, he's taking part in this project as well, which is a unique experience that we're working around. For our sponsors, we have Jim Bondi, who's in the back of the room. He is works in career services here at RIT, and then Chris Jansman does the same job, but out at University of Arizona. So, what the heck actually is JobSalt? And that's an acronym, and that stands for Jobs, Salary, Alumni, and Location Terminal. And so our kind of slogan there is add some spice to your job search. And so what we've noticed is that while there are tools out there at universities to help students find jobs, they often end up presenting a small fraction of jobs that might actually be available to the students. The tools are also rather impersonal and kind of force students to apply for companies without much background knowledge on that company, or in some cases there might be alumni that are currently working there that would be willing to be contacted and provide more information about the company. The tools don't really offer you, that are out there right now, don't really offer you a way also to compare salaries of other students that have gone to your university, and such as like, what's the salary for an SE student in California or in New York? And lastly, students often need help trying to find housing when they're actually out looking for a job. And the tools right now aren't really informative, and they're not really a way for students to kind of interact and discuss with other students to find out what areas are good to live in and what aren't. So the first thing really here that is kind of the foundation of JobSalt is the job searches. And what really differentiates this from what you'd get, say, if you went to like LinkedIn or Indeed and started looking at jobs, is that you're not getting just posts from that source. You're actually getting them from multiple sources. So when you would use our system to search for a job, you'd be seeing results that came from Indeed, results that came from LinkedIn, and even results from your own university's internal job postings. And then the other really big benefit of that is, since we have your university's information, we can link you to alumni that are currently working at that company. And so if you were to do that, you'd end up with a screen looking more like this, which now you're able to see, oh, hey, you know, I know this person graduated 4 years ago, they were in my major, they're working at this company. Maybe I should be ping them and try and get some help and find out more about the company that they're working at. And then after that, you might be like, okay, so now I've got an offer. What should I be expecting for compensation-wise? And then you can be able to use this screen where you can actually compare by both location and major what the salaries are, and be able to kind of help navigate to finding a fair salary for your position. And the last mock-up that we have here is for the actual the housing reviews. And the purpose of this is really, after you have a job posting, how are you actually going to be able to find where you might want to live? What's a good area and what's a bad area? It's really hard to determine that, and the tools that are around right now aren't really for students. They're just kind of in general. You know, you can look up apartment reviews or stuff like that. But it would be much more beneficial to find out, oh, I know a student that went to my university, interned in this area, or works in this area, and knows, like, hey, you know, you want to live in this area, it's really awesome, there's great transportation and everything like that. And then I wanted to backtrack just a little bit and talk about how we actually, or the benefits that we got from these UI mockups that I just walked you through, is when we were first designing the system, we had our vision and scope document out, and we had interacted with our sponsors, but we weren't really sure that we were heading down the direction that our sponsors envisioned. And after we had the documents, we started working, or the vision and scope, we started working on the SRS, and we were kind of heading down the same path. We had a lot of documentation, a lot of heavy detail, but we still weren't sure it was what they wanted. And then after we started creating these UI mockups, it really just changed the interaction that we had with sponsors. It was no longer kind of just about like what you saw in your head. It was now about, well, I see this button here, but how is that going to get me to here? Or I was expecting this to be there. And so we really found these mock-ups really, really beneficial. And then just some of the last points about kind of what our system is are really, we have a really strong focus on it being usable on both a desktop platform and a mobile platform. And what that entails is that we're going to create it as a website that scales very nicely all the way from your desktop, big resolution monitor, down to your mobile phone, and in both cases having a user experience that you're familiar with. And then the other big things are, like I mentioned, we have 2 sponsors at University of Arizona and RIT. Our system has to work with both. So we can't develop a system that works with RIT, we can't develop a system that works with the University of Arizona. We need to develop a system that works for both, and we'll get into more information about that.
To this end, we were talking to the sponsors. As you can obviously think, there are many different technology choices that would go into this and what might be better than others. Our sponsors did push for us to use C# and MVC because that is what they know, that's what they already know how to maintain and how to utilize. But they were open to ideas if we had some great idea that would just push the project forward. However, we did agree with them. The best technology for this, we decided, was C# using .NET 4, MVC 4, and the back end, we're using a Microsoft SQL Server. Again, that's what they have, already know how to use, and will make integration that much easier.
So with all of that in mind, we had to come up with an architecture for this system. And so we were really pushing for something that was modular design. And what that means exactly is we wanted to have a system where the core of it was very portable. You can move that around anywhere. And then the way that that system gets its data is from these modules that anybody could write. So that's the idea. We want to be able to have people write modules to collect data from different data sources. So if you look at the diagram over here, we have an example here. We have the internet as well as the school's database. We have our modules. We have this flock of modules being managed by our what we call shepherds. And each one of those is able to keep track of those sheep. And it sounds silly, but it makes sense. So those sheep are responsible for collecting the data from the source, converting that data into our internal data structure that can be passed around our core system, and then we can display that to the end user. So this allows the flexibility of a school to, if they have some sort of need for a new site that we aren't supporting, since we're only going to be doing modules for what has been requested of us. But in the future, if a new job site comes up, or say somebody wanted to get information from monster.com, they could write a module, drop it into a folder, and using the reflection technologies in C#, we can actually load up that module without ever having to modify the core system. We don't have to call the concrete class name. We can just load it up, and we know if we have an interface defined that we can just call these specific methods in order to get the information we need. And if we're fancy enough, we can do all of that during runtime, which would be great. So one of the main points of using this comes into play when we're working with authentication.
So with authentication, every set of infrastructure pretty much uses a different authentication system. There are a couple primary ones. We were going to implement a couple of them, so that way anybody deploying the system can choose between them. RIT primarily uses Shibboleth, which is what you've logged into. Whenever you go to SIS or something, that's a Shibboleth login. So we want to try and interact with that because that's primarily what RIT uses, as well as that is one of the industry standards. We did run into a problem with that of trying to get the connection information from ITS. They have not provided to us, so it's really hard to actually test and develop that system. So we did then go through and utilize the modular system to change the primary module to actually an LDAP one, which we are able to implement on this system and can therefore get the authentication working. This does also, though, therefore show how we can use this system for across universities. Let's say another university wants to use OAuth. RIT does use that. That's the same thing Google Apps uses, another pretty common one. Gives us more choices and lets it be easier to deploy.
So we use what we like to call a recursive iteration methodology for JobSalt, which is based around what we call cycles, which you can see here, the anatomy of a cycle, which consists of 6 steps. So the first step is an initial planning, then we move to a requirements gathering, then we move to a first draft or implementation step, where we can show our sponsors and anyone else what direction we're heading in. Then we have a feedback step where we take sponsor feedback and discuss any changes that need to be made. Then we have a rework step where we implement any changes we discussed in the feedback step. And finally, we have a release step where we commit our final draft of whatever we're working on. So each cycle has its own timeline with concretely defined due dates on our schedule for each of those steps. So as you can see, testing and validation are actually hard built into our methodology in the feedback and rework steps. We not only test our code, but we also test our documents and validate them with the sponsor before releasing them as final. So we organize these cycles in kind of a recursive-like way. So we have one overarching main cycle, which consists of other cycles, and that consists of other cycles, and so on. So each cycle on every level has the same 6 steps, but they're focused on different things. The inner cycles really focus on implementation-specific activities, such as writing code or writing the documents, whereas the outer cycles focus on the project progress as a whole. So no matter what level a cycle is, their respective steps are still hard-written into our schedule as milestones. So here's a diagram of how we organize them. So our outermost cycle is job salt as a whole. And the initial planning, requirements gathering, and the first half of our first draft steps are delegated to the first semester, which is its own cycle devoted to the planning and design of our project. We've already completed our requirements gathering, and all the requirements are pretty highly stable at this point. At the end of the first semester, we release a packet containing all of that planning and design after receiving feedback and reworking any artifacts as necessary. Underneath the first semester, we assign each artifact its own cycle to be worked on with its own planning, implementation, testing, etc. Steps before releasing it. The second semester is devoted to the implementation and testing of our system, which can be thought of as kind of the second half of the first draft, or the implementation. The feedback, rework, and release steps of our outermost cycle. The features are implemented in priority order to ensure the highest completion rate of job salt possible in the event of any scheduling slips happen. So I mentioned before how each cycle has a testing phase built into it. And we actually have, on top of that, an entire artifact cycle devoted to project testing and rework before release. So here, this is just a screenshot of our software requirement specification. It's just an example, because I want to show how much effort we put into writing our functional requirements. We try to make sure that each requirement is testable and specific, and we're going to use these as a guide during testing. So the SRS also has the added benefit of being almost a contract with the sponsors to prevent feature creep as much as possible and reduce, again, that risk of schedule slip. It also allows us to track progress on the code, which is essential for making sure we're on schedule. And it also allows us to tie any specific code issues to functional requirements in our document. We do want to do more usability testing, and we're going to try and work that into each of our feature cycles. But the exact schedule for the second semester will be concretely decided at the beginning of it. So this is just a quick example of our schedule. This is a snapshot from September. So you can see each artifact cycle is roughly 3 weeks, but it can be distributed differently depending on how much time we need. The artifact milestones are assigned to individual due dates on the actual days themselves, while any required parent cycle tasks, so overarching tasks, like doing this presentation is required for the first semester, are listed at the beginning of the week. So that indicates to us that we need to complete it by the end of the week.
So to further make sure that we're staying on track, we've been taking some metrics So for time tracking, we opted to use a Google Forms, and then we tied that into the lovely spreadsheet you see right there. It creates this pie graph for us, and it updates in real time. So whenever we go in to our Google form and enter some new time, that gets updated, and that's reflected on our website. And the reason we chose that was because it was the simplest to set up, and it's the most familiar to all of us, so that's what we've been using. In order to keep track of various issues, we'll be using Jira tied together with Stash for code hosting because the 2 and 2 go together very well. And the idea is that we will create issues in Jira for each one of the features we have defined in our SRS, and we can close those issues as those features get completed. So with all that, we can track the hours worked per person, the hours worked per artifact. We can see the number of issues opened per week as well as the number closed per week, and then we can have a ratio of the 2 of those.
So along this whole path, a few of the things that we've always had kind of on the back of our mind and had to really make sure that we manage well were some of the risks that I have listed here. The first one being really unfamiliarity with the technology. Coming into this, we had, like, some of us had background in C#, some of us had background with, like, SQL, stuff like that, but none of us had really worked specifically with C# and MVC. So it was really kind of throwing a hurdle at us at the beginning, which a lot of the kind of, like, necessities of those technologies we were able to ignore for the time being when we were working on the vision and scope and the SRS, which were really more focused on just what we want to deliver rather than how we want to deliver. But what we ran into is we started doing our architecture as our 3rd cycle in our first semester here. And what we found is we weren't really able to do an architecture well. We didn't really know what the technologies needed in order to be supported well. So what we ended up doing is we had a meeting with our sponsors, and we talked to them and agreed upon that it would be best to pause our work on the architecture and bring in our prototyping cycle a little early so that we could actually get familiar with the technologies that we had to use. And that's what we had done these last 3 weeks. And so now we have a firm grasp of the technologies that we need and how to really work with them, which leaves us to be able to then go back to the architecture before the end of the semester here and really produce a solid architecture rather than one that we thought would work but hadn't really been tested. So another issue, though, that we've had to deal with, and Ross touched on this one, was the issue of just being over-optimistic with our schedule, which doing the prototypes helped a lot. And then the other way is that we're, like Ross mentioned, we talked to our sponsors and found out really what priorities they have on the features and what ones they want to see the most. And we geared those towards the beginning of our 2nd semester here so that we really can complete this, get the most completion percentage possible for this project at the end of next semester. And one real big issue for us, though, is communication. Like I said, we have a remote sponsor, which is an issue. A lot of the teams are working on that. But we also have that 5th team member who is remote. And we've never met him in person, but he's working on this project too. And at first, we did a really kind of poor job of trying to give and delegate work to him and try and get feedback from him. And we were just basically giving him tasks and kind of hoping he would get back to us. And it really wasn't working, and we were pretty worried about that. But then we were able to come to a solution where now we started reserving the communication rooms, the telecommunication rooms, so that on twice a week we were able to meet with this 5th team member and really could treat him just like the rest of us and could really utilize his full potential there, which gives us an actual little extra manpower, which is quite handy. And finally, I'll just really quickly touch on this. One issue is both of the 2 remote members are in Arizona. They don't adhere to daylight savings time. That's interesting when we do. And so middle of this semester, all of our schedules got all messed up because we switched back an hour, but they didn't. And so all of our meeting times that we set up remotely, we had to then rearrange.
So finally, the current state of the project. Something that we're very proud of is that every deadline that we've assigned for ourselves has been met so far. We're really on schedule. Some of them we've even completed ahead of time, which gives us a lot of confidence for how our methodology and how our schedule is set up. We've already completed the vision and scope, SRS, and the prototype cycle, and we're in the middle of of writing our architecture and detailed design. And yeah. So, any questions?
So you mentioned that you are prioritizing, with the help of sponsors actually, feature set. I'm wondering if the authentication and shibboleth is one of those high requirements. Something that you are.
It is required to be able to authenticate. Actually, the primary system that we're looking at is called WebAuth, which is a more minor one with simplified shibboleth. Yes, that is definitely a priority. Unfortunately, if ITS doesn't get back to us with the proper information, it's actually physically impossible to interact with shibboleth at this time. But we should still be able to utilize the authentication.
So one of the things I didn't mention is that although we have a cycle for each of the features, there are overarching things that need to be done, like authentication and setting up our UI, things like that, which are kind of done concurrently alongside the features. So just because we're in a certain cycle for a feature doesn't mean that all team members are necessarily working on that feature. That's just what needs to get done at the end of it.
Yeah, I mean, I understand how, from the design perspective, you're trying to mitigate the risk, but at the same time, you want to be the first team who has been challenged by the shibboleth issue, and so I'm wondering how are we going to address it?
I have the information on how to set it up to get it to work, and I've wrote pretty much a prototype that'll let us test it, and actually in the middle of trying to set up my own shibboleth instance, so that way we can test it ourselves, even if RIT does not give us that information. However, until that is done, it's physically impossible to test. So
we do also, there's an open ticket right now, which actually Jim opened months ago, actually, requesting ITS to grant access to shibboleth. And since then, we've kind of pinged them back on that, trying to really get that forward.
Does that answer the question?
Yeah, I'm just wishing you.
We have a backup, though. That's
we have a backup. Yes, that is the plans to write that, but we do have a backup just in case ITS gets back to us.
Yeah.
On your time breakdown, you had over 50% of something. I couldn't.
Yeah. That was team meetings actually, and so about 50% of our time has been in team meetings, and that might seem a little high, but for us, that's actually working really well. One of the things that factors into that number, sometimes when we meet, we work on an artifact together, and we count that as a team meeting as opposed to counting it towards the artifact, so that increases the number. And also, we've had a really high kind of priority on communication, because that's one of our biggest risks is communication. So we've tried to meet as much as possible to increase that communication.
Also, when there's multiple people working in a meeting, all of their time just add on top of each other, so that inflates the number too.
Okay, so a couple observations then. One is, I would expect it's a challenge to keep the person in Arizona in the loop for that vast amount of time. Second, are you going to be doing the development increments as teams before? Or are you going to try and modularize your development work as well?
That is going to be more modular, but with a lot of the documents and whatnot, it requires a lot of talking about how we want, for example, the architecture. We're talking, discussing, debating how we want, what's the best way to do it, which is hard to do when you're not together.
Also, we're going to be kind of attacking the implementation according to those functional requirements, and so we're going to be opening issues for each of the functional requirements, and then logging time for each of those issues. So it should be it should be a little more fine-grained during implementation. So we're going to be moving over to Jira for implementation stuff.
Could you go to the slide that had the layout, the breakdown of the different cycles?
Sure.
This one?
Yeah.
I noticed at the end of the implementation and testing is integration testing. Does that mean that you're waiting to have all your features developed before working in integration testing?
I wrote integration testing. That might be a little misleading. It's going to be, I mean, as we integrate features when we move to the different feature cycles, we are going to be integrating and testing at that. I probably shouldn't have used the word integration testing. That's kind of overall testing of the system once it's complete.
Polishing, bug fixing, making sure everything is where it should be.
Finding and rebuilding bugs.
All right, let's thank the team.